I want you to imagine you're at this really crowded dinner party.
Oh, yeah. Like a totally chaotic, packed room.
Exactly. Silverware is clinking against plates. You've got jazz music playing somewhere in the background. A waiter is shouting out specials, and like 5 different people are talking at once.
Just a wall of noise.
Right, a wall of noise. Yet, somehow, you can focus entirely on, the whispered punchline of a joke from the person sitting right across from you. And for decades, we've basically operated under this assumption that your ears are doing all of that incredibly complex filtering. But what if I told you we were completely wrong?
I mean, it's a fundamental misunderstanding of our own biology, really. We tend to look at hearing as this simple input-output system. Sound goes in, meaning comes out.
Like a light switch.
Right, like a switch. But the reality is that the sensory landscape of human hearing is, well, it's less like a mechanical switch and way more like a supercomputer trying to decode a highly encrypted message right in the middle of a Category 5 hurricane.
Which is just wild to think about. And that's why today our mission is to completely dismantle and then rebuild how you think about hearing.
We really need to tear down the old model.
Yeah, because we're going to show you that it's not just an isolated function of the ear. It is this massive mind-body superpower that dictates, well, pretty much everything from your physical balance to your daily energy levels.
It connects to everything.
It really does. And we are drawing our insights today from this eye-opening text called The Symbiotic Network of Hearing, Balance, and Mind. And we're also looking at a detailed case study on a liquid nutritional supplement called ECHOXEN.
And, the value of this specific stack of sources is how it forces us to zoom out. It strips away all that conventional wisdom we grew up with and just looks at the pure mechanics of the nervous system as a whole.
Exactly. And for you listening right now, the stakes on this are entirely practical. I mean, whether you find yourself suddenly exhausted after trying to focus in a noisy office.
Oh, that brain fog is so real.
So real. Or maybe you're simply walking up a flight of stairs and feeling a little less steady than you used to. Today's deep dive holds the exact biological explanation for why that is happening. So, okay, let's unpack this. Because before we can understand how hearing affects your whole body, we have to debunk what is arguably the biggest, most pervasive myth in audiology.
Oh, I know where you're going with this.
Yeah, it's the idea that our ears actually hear anything at all.
That is the perfect place to start. Because biologically speaking, giving the ears credit for hearing it's incredibly inaccurate.
Right.
To really wrap your head around why, you have to trace the literal physical journey of a sound wave as it crashes into your head.
Okay, so walk me through the mechanics of that. Like a sound wave leaves a speaker in my living room. It hits my outer ear. What is physically happening in there?
Well, the outer ear basically funnels that wave down the ear canal until it physically strikes the eardrum.
Mm-hmm.
And think of the eardrum like a highly sensitive, tightly stretched trampoline.
Okay, a trampoline. Got it.
So that acoustic wave hits the trampoline, causing it to vibrate. Now, connected to the other side of that eardrum are these 3 incredibly delicate, tiny bones in the middle ear.
Oh, that's the hammer, the anvil, and the stirrup, right?
Exactly, yeah. And their job is purely mechanical amplification. They act like a lever system.
Like pushing a swing?
Sort of, but more like a piston. They take that vibration from the eardrum and punch it inward, acting as a piston against a structure in the inner ear called the cochlea, which is shaped a lot like a snail shell.
Right, the snail shell. But wait, the cochlea isn't filled with air, is it?
No, and that's the crucial engineering hurdle the body has to solve here. The cochlea is filled with fluid.
Oh, wow.
And fluid is obviously much denser than air. So those tiny bones have to strike the cochlea with enough force to create a literal physical wave inside that fluid.
Like dropping a pebble in a pond.
Exactly. And as that fluid ripples, it washes over these microscopic sensory structures called hair cells, or stereocilia.
Hang on, I need to visualize this. So we have an air wave that turns into a bone vibration that creates a literal fluid wave inside the head.
You got it.
And these hair cells are essentially, riding that wave like seaweed swaying in an ocean current.
That is a brilliant analogy.
Yep.
Yes, like seaweed. As the fluid wave pushes those microscopic hair cells, they physically bend.
Okay.
And when they bend, these literal physical trap doors on the tops of the cells get stretched open.
Wait, trapdoors?
Yeah, microscopic trapdoors. And this allows potassium ions to suddenly rush into the cell. That chemical rush creates an electrical spark.
That is unbelievable. So they are literally taking mechanical, kinetic energy and translating it into an electrical charge.
Precisely. They're biological translators. And the moment that spark is created, those electrical signals shoot rapidly down the auditory nerve.
Which brings us to the most mind-bending takeaway from this entire mechanical process. Like,
Okay.
up to this point, through the canal, the eardrum, the lever bones, the fluid wave, the bending hair cells, zero actual hearing has occurred.
None at all.
The ear doesn't know what a dog barking sounds like. It doesn't know what a piano is. Its only job is to collect environmental vibration and convert it into raw electrical data.
The ears are just data collectors. That is their sole anatomical purpose.
It's like a satellite dish on the side of a house, or a microphone in a recording studio. A microphone doesn't know if you're singing a beautiful opera or dropping a stack of books on the floor.
Right, it has no idea.
It just catches the raw acoustic signal. The actual picture, the actual movie, or the song is put together by the processor inside the house or the computer in the studio.
And in human anatomy, that processor inside the house is your brain. And that means if we want to talk about actual hearing, we have to travel up that auditory nerve into the cortex, because that is where the computational heavy lifting takes place.
So if the ear is just this dumb microphone, how much computing power does the brain actually need just to understand a simple conversation?
It is staggering, honestly.
Right.
When those electrical signals hit the brain, it isn't just one localized hearing spot that lights up. The brain has to instantly execute 6 highly distinct computational tasks, all simultaneously.
Wait, 6 tasks just from someone saying hello across a room?
Just for hello.
Yeah.
So first, the brain has to run what we call auditory scene analysis. It has to identify the specific speech signal and pull it out from the background noise.
Like at the dinner party.
Right. It is actively suppressing the hum of the refrigerator, the wind outside, and the traffic noise just to isolate that one voice.
Which is an incredible feat of processing that we take completely for granted, right?
Right.
Until we lose the ability to do it. What's next?
Next, it has to calculate spatial location. Where is this sound coming from? And to do this, the brain compares the exact microsecond the sound arrived at your left ear versus your right ear.
Oh, wow.
It measures the minuscule difference in volume and timing and performs instantaneous trigonometry to map the sound in 3D space.
Wait, it's doing complex geometric math just to tell me someone is standing to my left? That alone sounds exhausting.
And it's just getting started. Fourth, it has to cross-reference that sound with your memory banks to recognize the specific voice.
Okay, identifying the person.
Fifth, it analyzes the subtle pitch variations to interpret emotional tone. Like, are they being sarcastic? Are they angry? Affectionate?
Right, the subtext.
And finally, sixth, it routes the signal to the language centers to process the vocabulary and syntax so you actually understand the meaning of the word hello.
And all 6 of these massive computations are happening in fractions of a second, entirely seamlessly.
Instantly.
But it really makes me realize how fragile the system is. So what does this all mean for daily fatigue?
Ah, that's the big question.
Right. Like if I'm sitting in a noisy, crowded restaurant and I'm struggling to follow the conversation, is my ear failing? Or is my brain just getting physically exhausted from trying to run these 6 programs on a weak signal?
This raises such an important point, and it represents a massive paradigm shift in how researchers view audiology today. We call this phenomenon cognitive load.
Cognitive load. Okay.
If the initial signal being sent from the ear, our microphone is weak, fuzzy, or degraded because those hair cells are damaged, the brain doesn't just give up. It compensates.
It works harder.
Much harder. It steals resources from other cognitive functions and forces your processing centers into overdrive just to guess and decode the missing pieces of the puzzle.
So you are literally burning extra mental energy just to figure out if the waiter said soup or salad.
Exactly. Researchers are now directly linking hearing health to overall cognitive performance. Because if your brain is spending all its reserve bandwidth just trying to decipher muffled words, you literally have less computing power available for short-term memory, for quick reactions, and for sustained focus.
Wow.
It perfectly explains why poor acoustic environments leave you feeling so completely drained and irritable by the end of the day.
Your brain has basically been mining cryptocurrency for 3 hours just to get you through dinner.
That is hilariously accurate.
But here's where the sources take a really fascinating turn. We've established that hearing is a massive drain on the brain's power supply. But how does this connect to our physical bodies? Because we aren't just talking about mental fatigue here, we are talking about physical balance, right?
What's fascinating here is the anatomical real estate. The body is highly efficient with its wiring. Most people have no idea that hearing and balance literally share the exact same inner ear compartment.
Oh, really?
Yeah, right next to that fluid-filled, snail-shaped cochlea sits the vestibular system.
So they are essentially biological roommates.
Very tightly coupled roommates. The vestibular system is this breathtakingly complex network of 3 tiny fluid-filled semicircular canals. And just like the cochlea uses fluid to detect sound waves, these canals use fluid to detect gravity and motion.
So this is our internal 3D gyroscope.
Exactly. Each of the 3 canals corresponds to a different dimension of space pitch, yaw, and roll.
Like an airplane.
Right. When you turn your head, the fluid inside these canals sloshes around, bending its own set of microscopic hair cells. This tells your brain exactly which way gravity is pulling and how fast your head is accelerating.
And according to the research, this gyroscope controls an astonishing amount of everyday movement.
Oh, absolutely everything.
Like it's calculating your balance when you walk upstairs, when you turn your head to check a blind spot while driving, when you stand up from a chair, or even just when you are sitting perfectly still, maintaining your posture against gravity.
Every single one of those actions requires the vestibular system to stream constant, real-time data to the brain. But the brain doesn't just rely on the inner ear alone. It acts as a master command center.
It's pulling from everywhere.
Exactly. It takes the gravity data from the vestibular canals and fuses it with visual data from your eyes and proprioceptive data from your joints and muscles.
Proprioceptive data meaning the signals your muscles send to say like, hey, the left knee is currently bent at a 45-degree angle.
Precisely. Your brain layers the ear data, the eye data, and the muscle data to create a stable, coordinated reality.
I just love this imagery. It is basically like the inner ear is this high-tech co-working space. You have the hearing department and the balance department.
Right.
But they are sharing the same office building, the exact same fluid supply, the exact same blood vessels, and like the exact same Wi-Fi network to the brain.
And that shared infrastructure is the critical vulnerability.
Yeah.
Because they share this delicate biological plumbing, a disruption in that specific area of the inner ear doesn't just mean you need to turn the TV up louder.
That's much bigger than that.
If the fluid balance gets thrown off or the blood supply drops, both departments suffer. A degraded inner ear directly impacts your physical stability, creating vertigo, disorientation, and just a loss of confidence in how you physically move through the world.
Here's where it gets really interesting for me. I think society has conditioned us to believe that hearing loss or balance issues are just a switch that flips when we hit a certain age.
Oh, the getting old myth.
Right. You turn 70 and boom, the warranty expires on your ears. But looking at the mechanisms we just discussed, that's not true at all. It is about a very specific, cumulative biological wear and tear, isn't it?
Absolutely. The aging process in the inner ear is rarely one catastrophic event. It is a slow, compounding degradation of that shared infrastructure over decades. The sources point to 3 specific mechanical culprits. The first is mechanical shearing from noise exposure.
And we aren't just talking about standing next to the speakers at a heavy metal concert, are we?
No, not at all. We are talking about moderate, relentless daily noise. Loud traffic, power tools, lawnmowers, or just having your earbuds turned up slightly too high for hours a day.
Just that constant grind.
Exactly. Remember those tiny hair cells riding the fluid wave? When sounds are too loud, that wave becomes a violent tsunami. It physically snaps those delicate hair cell structures. And in humans, once a hair cell breaks, it never ever grows back.
Wow, it's permanently offline. So that's mechanical damage. What is the second factor?
The second is oxidative stress. So as your cellular mitochondria burn energy, they produce volatile byproducts called free radicals.
Okay, free radicals.
Normally, your body cleans them up. But when the inner ear is overworked, say, by constant noise or stress, it produces too many free radicals. These molecules act like microscopic rust.
Oh, rust. That's a great way to put it.
They strip electrons from healthy tissue, causing the structures of the inner ear to stiffen, malfunction, and eventually trigger programmed cell death.
So the machinery is literally rusting and snapping.
Yeah, it's bleak.
And the third factor?
Circulation. The inner ear is an incredibly isolated environment. It relies on a very specific microscopic capillary network called the blood labyrinth barrier.
Meaning it's at the absolute end of the blood supply line.
Exactly. It doesn't have backup arteries. So if your overall circulation drops due to poor diet, lack of exercise, smoking, or cardiovascular issues, the tiny capillary network is the first to dry up. The inner ear literally starts to suffocate from lack of oxygen and vital nutrients.
Which perfectly explains why the everyday habits recommended to protect your hearing, like regular cardio exercise, staying deeply hydrated, managing stress, and eating a nutrient-rich diet are the exact same things recommended for heart health.
They overlap completely.
If you take care of the blood flow to the building, All the offices in the co-working space stay open.
It is all one interconnected vascular system.
Yeah.
You simply cannot separate ear health from cardiovascular health.
But this brings up a really crucial logistical problem. If the inner ear is this highly isolated environment tucked away behind the blood labyrinth barrier, getting raw nutrients to those rusting, suffocating cells has to be an absolute nightmare for the body. Is that why our sources dive so deeply into the role of specialized nutrition and supplementation?
Yes. While nutrition cannot magically resurrect a dead hair cell, current research is intensely focused on how we can supply the biological raw materials needed to defend the cells that are still surviving and to keep that shared fluid and blood supply running optimally.
So let's look at the specific mechanisms of these nutrients. The sources highlight antioxidants first. Based on what you said about cellular rust, the antioxidants are basically the chemical rust remover, right?
That's exactly it.
They neutralize those free radicals before they can strip the electrons from the healthy ear tissue.
Precisely. Then you have specific vitamins and minerals. These aren't just generic health boosters. They are required to maintain the structural integrity of the nerve pathways, ensuring that the electrical spark created by the hair cell actually makes it up the auditory nerve to the brain without degrading.
The sources also point to amino acids, which are fascinating because they provide the actual structural proteins needed to repair cellular scaffolding after it gets battered by that fluid wave.
Building blocks, essentially.
Right. But this brings us to the case study on the supplement ECHOXEN. Because if I'm understanding this correctly, swallowing a handful of generic vitamins doesn't mean they're actually going to make it into the microscopic capillaries of the inner ear.
And that is the bioavailability hurdle. ECHOXEN is highlighted precisely because it approaches this logistical delivery problem differently. It is a premium liquid formula that combines carefully selected plant extracts, amino acids, vitamins, and minerals.
Wait, why is the liquid format so important scientifically? Is it just for people who hate choking down chalky horse pills?
Well, while compliance is a huge factor, people simply won't take what they can't swallow. The scientific rationale often leans toward absorption.
Okay.
These liquid extracts bypass the need for the digestive system to break down heavy pill binders and synthetic casings. The theory is that it offers a more rapid and efficient absorption of those botanical compounds into the bloodstream, giving them a better chance to circulate through difficult pathways like the blood labyrinth barrier.
That makes total sense. It's about efficiently delivering the payload. But I do need to step in here and act as the ultimate skeptic for a moment, just to manage expectations for everyone listening.
Please do.
Because the internet is full of wild claims, ECHOXEN, or any botanical supplement, is not a time machine. It is not intended to diagnose, treat, cure, or prevent any disease. If your hair cells are snapped from a lifetime of jackhammers, a liquid vitamin is not going to magically regrow them.
If we connect this to the bigger picture, responsible clinical experts universally agree with your skepticism. You should never look for a single miracle drop to fix an isolated biological failure.
Right. It is meant to be a complementary defense mechanism. You pair the efficient nutrient delivery of something like ECHOXEN with the macro habits, the cardiovascular exercise to pump the blood, the sleep to clear the cognitive load, and, the earplugs to stop the mechanical shearing.
Exactly. It is a holistic defense strategy for a deeply symbiotic network.
And that completely shatters the old paradigm. We really have to stop viewing our ears as these passive little cups glued to the sides of our heads.
To synthesize the sheer scale of what we've uncovered today, your ears are advanced kinetic translators. Your auditory nerves are high-speed fiber optic cables. Your brain is a supercomputer running instantaneous geometric calculations to map your reality. And your vestibular system is the gyroscope anchoring you to the earth.
And every single sound you parse in a noisy room, and literally every confident step you take on a staircase, relies entirely on this network functioning efficiently. And that is why you should care about the cellular health of your inner ear.
It affects everything.
When you make a daily choice to manage your stress or to deliver bioavailable nutrients to your bloodstream, you aren't just saving your hearing. You are actively preserving your brain's cognitive bandwidth, protecting your physical coordination, and defending your ability to engage dynamically with the world around you.
You're giving the supercomputer the power and the pristine data it needs to keep solving the puzzle rather than, burning itself out on static.
It is incredibly empowering once you understand the machinery. But as we wrap up this deep dive, I want to leave you with a brand new, slightly provocative concept to chew on, something that builds on this entire symbiotic model we just explored.
Oh, I am always ready for a curveball.
So, we know from the mechanics we discussed that the ears never actually turn off, they don't have eyelids. Even when we are fast asleep, those hair cells are riding the fluid waves, translating mechanical energy and sending electrical signals to the brain. The microphone is always hot.
That is biologically accurate. Your brain's thalamus might temporarily block the signal from waking you up, but the inner ear is relentlessly collecting and transmitting environmental data 24/7.
Right. So here is my thought prompt for you listening. If that constant, relentless stream of auditory data is so inextricably linked to our vestibular system, our spatial awareness, and our brain's processing power, does complete and total silence actually deprive our brains of vital spatial grounding?
Oh, wow.
We just spent all this time talking about feeding our bodies a balanced nutritional diet to support the hardware. But if the brain is a supercomputer that needs to stay fit, should we also be actively curating a sound diet?
That is a remarkably compelling angle.
Yeah.
If the auditory processing centers are a muscle, does locking ourselves in a state of sensory deprivation or, say, wearing noise-canceling headphones for 10 hours a day accidentally starve the processor?
Exactly. We think we are protecting the system by retreating into dead silence, but are we actually letting those spatial mapping and auditory scene analysis programs get completely out of shape from lack of use?
That's a scary thought.
Does the brain actually require a healthy, diverse diet of complex, natural sounds like wind in the trees or flowing water just to keep its spatial geometry sharp?
It really forces you to completely rethink not just your internal biological environment, but your external sensory environment as well.
It really does. Because at the end of the day, your hearing isn't just a volume dial on a radio. It is an intricate, fluid-filled, lightning-fast network working tirelessly to decode reality. And it is entirely up to you to ensure it has the structural support, the blood flow, and the right kind of data to keep you balanced, focused, and connected.
Beautifully summarized.
Thanks for joining us on this deep dive. Keep questioning the basics, keep exploring the mechanics of your own biology, and we'll see you next time.